Okay, now this circuit over here, this is 120 volts, and over here you have 10 and you have 5. Okay, sorry, this is 5. So you want to find voltage across 10 ohms. I will use voltage divider. So it is 120 into 10 divided by 10 plus 5. So whatever answer you get over here, say I'll write it over here, it's 120 into 10 by 15. 5 2s are 10, 5 3s are 15, 3 1s are 3 4s are 12. So it is 80 volts is the answer. So the voltage experienced across 10 ohms, okay, is said to be 80 volts. So what we do is over here, we'll have to put it over here, 120 minus 80. So the answer will be 40 volts. Okay. Now, this 40 volts has to be assigned a sign of plus and minus. So how to assign it? This polarity has to be compared with this direction. So if this direction, this will be plus, this will be minus. Since both the polarities across AB are matching, okay, it has to be plus 40 volts. If they were not matching, it has to be minus 40 volts. Okay. Now we have found out VTH1 has to be 40 volts, that is the voltage experienced across AB just due to 120 volts. Next, you will find the voltage experienced across AB because of 6 amperes. Okay. Now, so again for that over here we will use KVL. Okay. So you consider a dummy resistor to be connected across your terminals AB, and with that you check for the flow of current. So this will be plus, minus, this will be plus, minus, this will be plus, this is minus. This is the polarities with this flow of current. Now take the innermost loop and write your KVL equation. So if I take my innermost loop, when I am traveling across 5 ohms, I will have a drop of minus 5, plus to minus is minus 5. When I rise up over here is plus VTH 2, okay, equated to 0. So what I ultimately want is VTH2 is equal to voltage across 5 ohms. Now, if you notice there's a current source, the current is splitting into 5 amperes and 10 ohms. So if I know the current in my 5 ohms, I can find the voltage across it. Now if you check, since this current source is providing for current in 5 amperes and 10 amperes, to find the 5 amperes current, you use your current divider rule. Okay. So if I use my current divider rule, source current is 6. Denominator sum of the resistance through which this current is flowing, so it is 10 and 5, 10 plus 5. In the numerator you have to put the other resistor, which is in this case is 10. And the answer that you get will be your current in your 5 ohms resistor. Say it is X. Put X over here into 5, that will be the magnitude of voltage. Okay. So say it is, the voltage is 5x. Now you have to assign it a sign plus or minus. For that, you check this polarity with the original polarity. This is plus, this is minus, this is plus, this is minus. Since both the polarities are matching, this answer comes out to be plus. Okay, this comes out to be plus 5x. So that is your voltage over here. Fine. Now once you get, this is your VTH2. Now, you have found VTH1 as 40, VTH2 you got as plus 5x. Your final VTH will be plus or minus VTH1 plus or minus VTH2. Okay, VTH1 is plus 40, VTH2 was plus 5x, whatever is the answer, it is positive. So, your final circuit comes out to be this was your RL which you have calculated originally. RL and RTH would be the same. VTH answer you will get it from here. Now one point I would like to mention is if VTH answer comes out to be negative, okay, no need to worry. It only means that instead of connecting the top positive terminal of a battery on top, you have to connect a negative terminal of a battery on top. It doesn't mean that your answer is wrong. And you get a minus depending upon what are the polarities you have got over here. Okay. So this is what you get. VTH, RTH. Now, your problem they told you to find the maximum power. To find maximum power, answer is VTH square by 4RL. VTH you have calculated, put it over here. RL also you have calculated, put it over here. You will get the maximum value of power. So when you are told to use maximum power transfer theorem, okay, they will tell you, the problem will usually have two parts. First they will say find the value of R, so the maximum power comes from the source to the load, okay. That method is the same as how you find your RTH by Thevenin's theorem, or to find the effective resistance between any two terminals. Get your RTH, that RTH and your R will be the same. Then you have to use Thevenin's theorem to find VTH. Or in other words, what you can do is, when a circuit is given, except that resistor, the entire circuit has to be replaced by your Thevenin's equivalent circuit. Okay, RTH and VTH that you have. So what you do over here is, this VTH you have to use using Thevenin's theorem, RTH you have to find using Thevenin's theorem, that is Thevenin's effective resistance, Thevenin's effective voltage across the terminals AB. Put them over here, put the value of R will not be given to you, write the symbol for R. The value of R will take the same as value of RTH. So the value of resistance of R will be the same as the value of RTH. The value of VTH will be a Thevenin's voltage, and maximum power can be calculated using this formula of VTH square by 4RL. Okay, that is how you solve using maximum power transfer theorem. You need to know Thevenin's theorem on it.